got a bit of extra time today, so I'm going to take a look at a couple of sudokus. Let's have a look at this Super-Fiendish from today's edition of the Times and see how we get on with that. Come on, computer. Okay. Funny grid geometry today, so as usual I'll make the notation that we've talked so much about in other videos. This has got to be a 2, just by simple Sudoku rules without doing anything clever. It's got to be a 9. Phone is buzzing at me. Oops, why is it doing this? Sorry about this. I thought this was a... It's always a bit terrifying of this sort of geometry in the grid, because it almost feels like you have to check all of the rows and columns that have 5 digits already in them. So like you can see this column here, we need a 1, 3, 6, 8, and sort of wondering whether or not I need to really go along and check each of these possibilities to find the next obvious way forward. I don't really want to do that because I don't think it's it feels like a lot of a long-winded effort to solve the puzzle. Okay, but if we have a look at this row here, we can see we have to place 1, 3, 5, 7. And the interesting thing is that we have a 1 and a 3 here. So we know these two numbers here have to be 5 and 7. But they can't be 1 and 3. And look, there's a 7 here. So that probably is the next step we were intended to find in terms of the solution path. These computer-generated puzzles, I'm never sure whether they do have sort of a most efficient solution path that one is expected to find. I like to think that they would have, but I somehow doubt that the people who generate these puzzles, or the programs that generate the puzzles, think about that. I think they just come up with something that works. 5, 8. So you can see this square and this square now have to be 1 and 3, and I'm not allowed to notate that using this method of notation that we recommend, so I sort of have to try and just keep in my mind that fact as we go through the solve. About this middle row, is there anything we can do with this? So we need a 1, 3, 5 and 8 here. That can only be a 1 and a 3 as well, so we have 1 and 3 in both of these positions. It's got to be a couple of 5s in there. This 7 here gives us a similar pattern down here, which might be... Oh, in fact that gives us a 7 here. 7 and 1. Just to place 1s into these positions. 3, 8, 9 to place in this box. So that's going to give us a 3 here. That's going to give us a couple more pencil marks into these two positions. The box is getting quite congested now. This cell can only be an 8 or a 9. Again, I'm trying to just bear in mind these cells that have a very, very restricted pattern. This row, 3, 5. This cell here. There's a 1 checking this cell, a 3 checking this cell, and an 8 checking this cell. So this cell can only be a 5. Let's write that in and see if that's going to help us make any more progress. Gosh, that's annoying. It's not going to. It does do something interesting though. If we use this column again here, you can see this cell can't be a 5. Now that means that the 5 in this 3 by 3 box has to be either in row 1 or row 3. And if we scan across here, we can see also in this box, the 5, once we place it, will either be in row 1 or row 3. This means that in this box, the 5 has to be in the central row. In fact, we could see that another way because the 5's checking here and we already have all of these numbers in. But the way I first spotted it was by noticing this sort of X-shaped pattern in these two boxes. So it doesn't allow us to do very much actually, just make another pencil mark, but we'll do that and carry on. So now we've got 1, 3 and 8. No, not quite. And now we can, in fact we can use this column here, column 7. So what do we have to place in this? This 4 and 8 are useful. Oh, I'm not sure what happened there, but the 2, 3, 5 we need to place obviously, and there's a 2 here. So in fact that could have just been written in as a 2 a while ago, which would have given us a 2 here, and a 2 here. These two cells therefore have to be 3 and 5. We can't see which way around that is, but we can write the notation in. And that is a little bit useful. Again, we've got the same X-type shape here with 3's. You can see that if this is a 3, this will be a 3. And if this was a 3, this will be a 3. So again, the 3's in this box have to be in the external positions like this, in columns 1 and 3. Now look down, we've got the same thing again. We've got 3's in these two, in this X-type pattern. So again, once I go up here, I know the 3's have to be like this. And it almost cracks it, not quite, but almost. We've got 3's in these two positions, and 5's in these two positions. What else have we got left to place here? 4's and 8's. No, that's not going to take us any further. Let's have a look at this box because we've got the 3 and the 5 in there now. So we've got 1, 4 and 8 to place. There's a 4 there, so that's going to give us another pencil mark. And that gives us this number over here, so that's got to be a 4 now. This box is getting so congested. 4 here and a 4 here. Ah! Nice. Okay, and finally we can make use of all of this sort of work we've been doing with 3's and 4's. Look at this 4 here in this box. This is checking this position. And we've got exactly the same logic that I did with the 5's we can do with the 4's. We know that the 4's will be in one of these 4 positions, and looking across here the 4's will be in one of these 4 positions. So again we've got the X shape here. Therefore the 4 over here has to go in row 2, which means I'm going to be able to place it here because it's the only place it can go. That 4 there is going to mean I can also place the 5 over on the left hand side. I'm hoping this 5 will be useful, and it will, because now we can place this 5 here, and that's going to give us this 3, which is going to give us this 3. All of a sudden we're starting to make, I think, proper progress towards the solution. So what are we left with here? 6 and 8 to place, and we can't quite resolve how, but we can notate that now. And here we're looking at 8 and 9. And now it looks like the central row, this 8 here, is going to, we've still got to place 1 and 8 in this row, but this can't be an 8. This has to be an 8 over here, which allows us to place the 8, the 1 and the 4, and the 1 here, and the 1 here, and the 1 here, and look, everything is chaining now, which is yeah, this should be most of the way to the solution now, I think. Let's just tidy it up with all of the pencil marks we now no longer need. What do we need up here? This has to now be a 4. Five, 8 in some order here. Again, we can see here that the 8 is going to be in, well, actually it's going to be in one of these two positions. So we've got the same logic again in this top thing. So just an 8 here. We can place the 6 now and the 9, which means that's going to resolve all of this. It's going to be a 9 now. So this has to be an 8, this has to be a 3, and this has to be a 3, and this has to be a 5. Which means this has to be a 5, this has to be a 6, I think. Which means 6, 8, 4, 8, 5. Okay, so an interesting solve today. I probably haven't found the most efficient way, but there were a couple of points there that were relatively interesting, and I hope you know, showing the value of the notation that we recommend. And we'll see you again for another Cracking the Cryptic soon. Thanks for watching.